So for this problem, it says a motorcycle traveling at 20 meters per second increases its velocity 30 meters per second. If the motorcycle traveled 80 meters during the speed increase, what was the car's acceleration? So the first thing we want to do is write down what we're given in the problem. So it says a motorcycle traveling at 20 meters per second increases its velocity to 30 meters per second. So that means the initial velocity is going to be 20 meters per second, and the final velocity is going to be 30 meters per second. So let's write that down first. So then it says if the motorcycle traveled 80 meters during the speed increase. So what we can do is we can assume that the initial distance, di, can be 0. So di is going to be 0 meters. So then it's going to travel 80 meters. So the final position, df, is going to be 80 meters. So let's write that in our givens here then. And the last part of the problem says, what is the car's acceleration? So we're trying to find the acceleration a. So we have our givens and we have our find variable. Now we want to find an equation here that contains all these variables. And what we can do is we can plug in what we're given and then solve for a then. So looking at the kinematic equations here, this equation contains all the given variables and the variable a. So we can use that then. So we can plug in what we're given and then solve for a. So I'm just going to write down the circled equation here. So we know the initial position di is 0, so we can just cross it off then. So this variable is 0, and it'll simplify things a little bit then. So the other variables are not 0, so we need to keep those. Okay, so what we could do is we could solve for a without plugging in values just yet. So let's go and solve for a algebraically. So what we can do is I can move vi squared to the other side then by subtracting vi squared. And then I'm left with 2a df on the right side. Now I just want to solve for a, so I could just divide both sides by 2 df then. So I have an expression for a now, so now I can plug in the values for vf, vi, and df. So now if I plug all these numbers into a calculator, I get the value of 3.12 meters per second squared. But let's keep an eye on the units here though. So for the units, I have meters per second, so that's going to get squared. And the same thing for the 20 meters per second, that's also going to get squared. So my value is 3.12, but then my units for the numerator are going to be meters squared divided by seconds squared. So I have meters squared per second squared in the numerator, and that's going to be divided by meters, because I have meters in the denominator. So I have meters squared and I have meters here. So this meter is going to cancel, and the meters squared is just going to be meters now. So I end up with meters per second squared, which are the units of acceleration. So my final answer is going to be 3.12 meters per second squared. So it'll give me the car's acceleration.